Hello class, this is a video tutorial on the generalized pigeonhole principle. So in the previous videos or the previous concept, we saw that if we saw that there were more objects than there were pigeonholes, then we saw that at least one pigeonhole or position must contain two or more objects. We're going to generalize this, and rather than think of it as just discrete objects, it can be n number of objects and k number of positions, and n must be greater than k, then at least one position must contain n divide k number of objects. In the case of discrete numbers, n over k is to be rounded up or down accordingly to the problem, and some further calculations are to be applied to the remaining decimals or remainders if this division here is going to be not an integer. So let's take a look at the first example demonstrating this. So a group of 75 people are to be organized into 4 teams. If the team sizes are to remain as equal as possible, big emphasis on this, how many people will have to sit out? So let's assume that we want them to be perfectly equal teams. And in part 2, what is the most number of people in one team? So assuming that no one sits out, well, what's the most number of people in one team if it has to remain equal? So first, let's recognize what are the positions and what are the objects. As we saw, we'll treat the positions as k. So in this case, k equals, well, 4 teams is what we're going to divide them into. So k equals 4, and simply n is equal to 75. Well, by the general pigeonhole principle, 75 over 4, if you type that into your calculator, you will get 18.75. Now, this obviously doesn't make sense because we can't have 18.75 people on one team. Well, if it has to remain as equal as possible, how many people will be on any given team? Well, for this, we're going to have to round down. So, in this case, we can say that each team will have at least 18 members. Now, let's consider what this means. If 18 people are to be in 4 teams, well then 18 times 4, that's going to be 40 plus 32. It's going to be 72 in total. Well, consider there was supposed to be 75. Well, that means 75 take away 72 equals 3. So 3 people sit out, because 3 people cannot be placed into any team, because then it will no longer be as equal as possible. Well, an alternative way we can calculate this is just consider the 0.75. So 0.75, and we multiply that by the 4 teams or the 4 positions, and you still get 3 people that have to sit out. Okay, so I hope that gave you just an insight into this idea of n divide k and rounding up or down, and then doing some calculations to the remainders or the decimals. Okay, so now continuing this, if the team sizes are to remain as equal as possible, what is the most number of people in one team? Well, since there are already 18 per team and 3 sitting out. If we're to keep this as equal as possible, we could place those 3 people onto 3 teams. So no need to write this out too much. We can just have this as one answer. Therefore, 3 teams can have 19 members. And that there's simply the answer that we're looking for. Because dividing each one into the 3 teams that could fortunately have them, it'll be unbalanced, but that is as equal as possible. Okay, so the main thing so far is this idea of, multiplying the remaining or the decimal, or taking only the whole value and multiplying it by the number of positions and figuring out how many people are not included into the count by the generalized pigeonhole principle of n divide k. So I hope that gave you an insight into this. Hope to see you in the next video where we go through a few more examples. Here they are. You can give them a go now. In any case, hope to see you then. Best of luck.